what open education fundamentally represents is this idea of democratizing access to skills that you might not otherwise have access to. And so I hope that we can work together as a scientific community to increase awareness around the value of these tools.
Hi, I'm Stephanie Tumampos, and you're listening to Down to Earth, the show where we talk to incredible geoscientists about their science and its impacts on our planet. This season, we're speaking to a wide variety of folks to investigate all things open science. I don't know about you, but when I'm stuck with a coding issue, I immediately turn to Stack Overflow. This platform, in addition to YouTube, is an excellent resource for learning how to use the tools for my research. But I definitely experience some issues with these platforms. For example, I often have to sift through lots of different videos or answers to find the one that works. As well, it's really hard to know if the person offering the solution is actually credentialed or knowledgeable. So how will open education address these types of issues, and how do we ensure that tools are accessible to all? These are some of the questions I'm addressing with an open education expert in today's episode. This episode of Down to Earth is brought to you by the IEEE Geoscience and Remote Sensing Society. The GRSS is a community of passionate researchers and practitioners who are working to benefit society through their science, engineering, education, and applications. This year, GRSS is excited to collaborate with the NASA Transform to Open Science initiative to celebrate the Year of Open Science with a whole Down to Earth season devoted to this very topic. To learn more and get involved in the year-long events and celebrations, visit science.nasa.gov and search for Open Science.
When I was at CU, I discovered the words open education. And I was like, oh, I guess I'm an open education advocate. But frankly, I started actually doing this like 15, 20 years ago. But it wasn't until maybe the past 5 or 6 years that I identified that term of open education being the thing that I have been doing.
This is Dr. Leah Wasser. She's the founder and executive director of pyOpenSci, an organization devoted to building a supportive community around the open source tools that drive open science.
When I was at CU, I was teaching Python, and I started to teach Python because it was just one of the most popular languages when you look at the career job market. And as an educator, I found myself digging through package code to figure out how to do stuff. I wanted to process remote sensing data. I wanted to teach my students how to do this, and I had to go through really, convoluted pathways to figure out how to do it in Python well.
While Leah hasn't always labeled her work as open education, she's been creating open education tools and resources for over 15 years. One of the most well-known open education portals Leah has helped build is earthdatascience.org. This site, developed by Earth Lab at University of Colorado Boulder, features several hundred lessons related to earth sciences, and all of it is freely accessible to anyone and everyone. From this and other experiences, Leah has accumulated a wealth of knowledge about how to build open education tools, how to make them accessible to broader audiences, and how to find funding to maintain them. So let's start with the basics. What is open education? Can you provide us with a definition?
So, at its most basic, this idea of open education is making education resources freely available. Often we see that it's in an online format, and ideally it's accessible. However, I like to kind of take that definition a step further to think about open education as learning resources that really democratize access, because you can publish lessons online and make them open and make them, available. But if you're really putting out quality lessons and making sure people can find them and discover them, you're really democratizing access to resources that a lot of people don't have access to. So that's the step that I like to really think about and focus on whenever I'm thinking about open education.
And when you say education resources, does this mean resources about open science in particular or other types of education resources too?
Um, Generically, open education could be any topic. Open education resources that I've worked on have all been about open, reproducible science. and empowering communities that may not otherwise have access to learning those skills by publishing those lessons online, licensing them in a way that people can actually use them to teach and to run workshops and to bring them into their curriculum at universities, and just make that content accessible to a whole new demographic of users who wouldn't otherwise have access to them.
One well known open education portal you've worked on is Earth Data Science. So, can you tell us about this project and what inspired you to create it?
Yeah. When I was at NEON, previously, National Ecological Observatory Network, I had built this portal there to teach people how to use NEON data. So I started watching the use of the online lessons grow from like no one knew about the website to 1,000 people a week to 2,000 people a week to 4,000 people a week. And I was like, wow, this is crazy. People really want these skills. So I took that with me to CU in building earthdatascience.org and kind of took it to the next level. And so I took kind of the neon concept and applied it to a full class. And that was the Earth Analytics Python class, was the first one I put online. Started in R and then I migrated it to Python. And it started with, a dozen lessons and ended up, several hundred lessons. And I just started putting more and more content online. And it became this great resource for the students because they were able to, if they missed a class, they could read the content online. They could watch the video if they wanted to do that. And so that's kind of how it evolved.
From this experience, what do you think is important in open education, maybe beyond developing materials and publishing them?
Sure. So it's really interesting because there's a lot of effort that goes into creating online content and publishing lessons and such. But there's a bunch of other pieces that I think aren't as often considered when you think about these lessons. So one of those is licensing. And so Creative Commons is a really common license to use. But things like putting on a no commercial clause, as much as I understand why people might want to protect their work, once you do that, you limit how the content can be used. And so an example of that is I have done some work with tribal colleges and empowering them to have the resources to teach data science and open reproducible science. If I had a no commercial clause on my materials, technically they couldn't use them. Now, I hope that they still would. But that no commercial, once there's a financial exchange involved, like tuition, for example, as high or low as it is, you start to prevent communities inadvertently from accessing the materials. So I think that that's really important. The other piece that I really think a lot about when I think about open education is that it needs to be more than just a let's create this thing and publish it online. I really think of these resources in the same way that I think about open source and any software, in fact, as things that need to be maintained over time.
Hmm. Well, let's talk more about this aspect of living resources. What are some of the challenges when it comes to developing and delivering them?
There's numerous challenges. I mean, the first is just making sure that they're up to date. And one of the ways that I've been able to kind of mesh open education resources into existing programs to target that issue specifically has been to use them in workshops, use them in trainings, use them in courses that I'm teaching already. And what's really great about that is that they have this thing they can look at later or during. And if they find mistakes, if you encourage them to let you know about those mistakes, that's one way to kind of keep the content up to date by just using them actively. Another thing that I think is a little bit harder to do, but also really important, and it's something that I did with earthdatascience.org, is we actually tested every lesson end to end before it got published online. And so that was essentially this idea of creating infrastructure around making sure that if you're talking about open science and data science, that things are up to date and current. Another thing that you can do in terms of like getting feedback in my classes, I'd say, hey, you'll get participation points if you report bugs and issues the lessons, and the students would do it. If your content is truly online, one option could be having comments at the bottom, like, do you have feedback on this lesson? So that is one other way to kind of collect information from your users. In terms of students actually getting the information from it that we hope that they are getting and they're actually learning. I think that's really challenging. And that, I believe, involves some kind of evaluation, like checking in with the students. Hey, did this make sense to you? What did you learn from this lesson? Like actually doing some interactive assessment of what did the students learn. I've seen some online platforms where they have little quizzes and those types of things just to kind of check in to see if people are kind of following along. But in the courses and workshops that I used to run regularly, we always did some evaluation around the content. And that included everything from like whether they could read the page and the content to whether, the terminology on the page was defined in a way that they could follow along and we didn't lose people, to was this a valuable resource in terms of what you were hoping to learn from that content. So those are a few things that I think begin to address some of the challenges with these types of resources.
Now, I'm sure there's a lot of time and effort put into deciding open education, but when folks are talking about this topic, deciding open education, what else beyond testing should they keep in mind in terms of design and release?
Yeah, of course. So, some people are very, very visual, so they might want to watch a video. Some people, like me, have no patience for video and they're going to watch it at like double speed. I had lots of students that did that. So
Same.
we'd actually, oh, you are too. Okay, great. We're very like-minded, Stephanie. I love that. So, you have the like, I need things to slow down. I'm going to watch this and kind of follow along. You have the, I can't focus for that long or whatever. It goes too slow. Let's speed it up. You have the people that want to just sit and read. You have the people that are going to skim those headings and look for graphics and captions, and then maybe they'll go back to the sections that are most important. So a few of the design elements that I like to think about when teaching with open education resources is, one, making sure we're addressing those different types of learners. This is a lot of effort, but these are the different ways that people like to engage with what I like to call student-directed learning, where they select how they want to learn. There's things that you can do to optimize the design, like having really, really useful headings and subheadings that help the user that's going through the resource understand what they're going to learn in that section. Being really clear about headings and subheadings and breaking the content up so it's digestible, that's also going to help you with search engine optimization. So those are the people that are going to be Googling, how do I open, Landsat data in Python? And if your content has enough of that really in the body of the content and in the headings, that's also going to help users and search engines discover that content as well. So there's a lot of different pieces associated with quality content and things that I think about as best practices for open education resources.
In educational design, often the designer is thinking about a very targeted learning audience. But I would imagine in open educational design, the designer also has to think about folks outside of a targeted audience. Is this the case? How do they make the materials accessible to a broader audience?
This is really hard. That's a really great question, and I don't know that I have the perfect answer, but I can tell you some things that I like to think about just generally with creating web content. So content online um, that has some sort of science flavor. One is just really thinking about the level of writing and what group of people you're targeting. So if I'm creating an online lesson, I like to think about writing at like around a 12th grade level. And that level is often accessible to a really broad range of people that maybe are interested in science and open science and data science, but they're not going to be the people that are reading those scientific journals. This is not dumbing down. This is just making the language more accessible to more people. And at the same time, those folks that are reading scientific journals, you're not going to upset them by using language that's just really easy to understand and digest. You're just making your content a little bit more accessible. So I think that writing style approach is one way to make things more broadly accessible. And there's a whole other suite of items that I am not the best or the most perfect expert on, but just related to accessibility. So thinking about things like people with screen readers and people that have various disabilities that might not interact with your content the way someone that doesn't have any of those disabilities might. They might have other needs. So that's a whole other web accessibility topic that is really important. But if you bring people in that are experts in that area and you get people to test the content that actually have those disabilities and are dealing with this every day, like that's a next level of making your content even higher quality. And this takes a lot of time. But if you really want to get into that space of creating accessible material, it's something that I think is really important to consider.
What about the issue of credibility or the topic of credibility on open education? How do learners know that the course or materials are designed by a credible source?
That's a great question. And I've been thinking about that one because it's really hard. And I don't think I have the perfect answer for you for that either. But I can tell you about some conversations I've had with others.
After the break, we hear Leah's thoughts on the ways we can determine an open resource's credibility. I'm also interested in her thoughts on sustainability for these resources, particularly since regular testing and maintenance is important. In an open science environment, how is she financially sustaining projects like Earth Data Science? Finally, I'm really curious to learn more about her experience with open peer review through her organization pyOpenSci. From what I understand, they actually support maintainers in open source communities by assessing Python packages. Up-to-date packages would certainly make my workflow more efficient, so I'm eager to learn more about how pyOpenSci does this. Stay tuned.
Are you a student or recent grad ready to reach your full potential in the geosciences? Then you need to join the Geoscience and Remote Sensing Society. With over 75 chapters in 94 different countries, you'll connect with a diverse community of professionals, experts, and advisors who can inspire your science and help shape your career. Find support and fellowship as part of our Young Professionals Network. Advance your skills through our GRSS schools, student travel grants, workshops, and more. Be at the forefront of geoscience research by joining our technical committees and network with geoscientists from around the world at IGARS, our flagship conference. Our incredible international community is ready to welcome you. Learn more and get connected today by visiting grss-i-eee.org.
Welcome back. Today we're talking about open education with Dr. Leah Wasser, founder and executive director of pyOpenSci. Now, I don't know about you, but I feel there's nothing worse than searching for a video to learn how to open a netcdf4 file, only to realize 2 minutes in that the creator doesn't actually know what they're talking about. Between you and me, I secretly hate these files, although admittedly, they're super efficient in storing data. Anyway, I'm very interested to learn how Leah thinks we can avoid this issue as open education tools become more ubiquitous. Here's what she had to share.
I think the credible author, like the authorship is one thing, but let's just focus in on the resource itself. How do we evaluate whether this is a good resource to use in a class? I think what's really difficult there is that every person who is teaching, if you're teaching the content, you have your own style, you have your own background and expertise, you might have your own data that you want to use with that lesson that's different from what's in it. And so the bottom line there is that you're going to almost always want to modify the content if you're using it for teaching or workshops. So why that makes things more complicated is thinking about having some online repository of lessons becomes more and more complex because you're going to have multiple versions of lessons to teach certain audiences and certain instructor teaching approaches. Another effort that I've seen that's really great in terms of credibility, and it's kind of in line with what I've been doing with pyOpenSci for software, is this idea of peer review. And so there's the Journal of Open Source Education that you can submit lessons to, and it's a wonderful group. There's great people there that are really dedicated, and they will review your lessons. And so then you get a DOI. It's a citable thing, and that's a great check mark of this is a high quality resource. But one of the challenges I encountered with Jose, and by the way, I love them. So this is not in any means a negative comment. It's just one of the challenges with a review. I tried to submit some of our lessons to them, and our content was so thick, so heavy. There was just so much there that they just physically, it's all volunteer reviewers, and it was too much for them to actually manage in a review. So there's some limitations there on like what those types of wonderful open volunteer efforts can actually support. So I think I'm answering your question with it's complicated. And I really don't know if there's like one tried and true way of vetting materials. But one thing that I would throw out on the table, if there was some way to see how current materials are, and if we had some standards around this was last updated, a month ago, so users had this sense of like, oh wow, this is something that's getting used and getting updated. Maybe that's a way to start understanding the quality of a resource. But boy, that's a really, really challenging question that brings up a lot of different things.
Well, maybe the testing piece is also part of determining credibility. Like if designers shared their testing results, perhaps those results would help demonstrate the credibility of the materials. Plus, sharing the process of design would adhere to the ideas behind open science in terms of sharing data and source.
I think that's great. In fact, what you're saying is kind of bringing up again some of the stuff we're thinking about with pyOpenSci of like, how do you tell if an open source package is high quality? And one of the things that you see in the open source world that applies to open education, and we had some of this on our lessons if you went to earthdatascience.org, is like a badging system. And so what that badging system would show you is like if it's been peer reviewed, if the tests, had run and it was passing. So it's a green check versus a red, like, oh, this is not passing, this is not running. I don't know if that exists as like a standard for publishing open education resources, but I would love to see something like that. I think it would be great.
So you've mentioned pyOpenSci a few times, and I'd love for listeners to know more about this community you founded. Can you tell us more about it?
Oh, yeah, great. So this these days is my other favorite topic, open education, and then we have all the open things. And so pyOpenSci is a diverse community that is going to and is supporting the open source tools and specifically the Python scientific open source tools that really drive open science. These tools are often maintained by volunteers, and there's not support for these communities. So pyOpenSci is this diverse supportive community around those open source tools. We have an approach that includes open peer review. And so what that means is that a maintainer submits a package to us that's Python focused, and we review the package, but we review it in a way that's specific to Python packaging standards, and we provide guidelines for what that packaging should look like. And when I say packaging, I'm talking about the infrastructure of the software, so what you need to actually install the tool and to run it to process your code, but also things like usability. So it's to try to really enhance that ecosystem for scientists, but also to provide support for these maintainers that are doing all of this work and not getting credit. And through the peer review process, they will add a citable DOI so that if you use a package in your paper, please cite these packages so they get credit for this effort and they can demonstrate that people are using it in a scientific application. And then we also have a partnership with the Journal of Open Source Software, which is another layer of actual publication that they can take that additional step to get a DOI or a citable identifier that actually will show up in your ORCID ID account and that kind of thing. So it's a cross-ref enabled DOI. So that's pyOpenSci, and we also will be doing training and education around both Python packaging, contributing to open source, and some of the skills, this open science skills that you need to use these packages. We're going to be doing training in that space as well.
So pyOpenSci does this full review of packages. That's really valuable in the open science community. But can you clarify what makes this review process open?
Oh, that's a great question. this idea of openness and what makes it open is if you're familiar with GitHub, github.com. So this is, it's kind of social coding in a way that you can interact with people and you can follow people and you can create these, they're called issues. Essentially, it's like a web page and you can go through and you can see every comment that someone makes about the package. So you try to make peer review about embracing, improving the content of the package and the usability of the package. And you try to make it a positive dialogue where the reviewer and the maintainer or the author can talk to each other about how that package could get improved. And it's my hope that over time that our reviewers will also be able to submit what's called a pull request, which essentially is a way to make changes to the code or changes to the documentation. And that's going to help the maintainer. So we don't want the process to be too hard on the maintainer, but we want to make sure that the tools in our ecosystem that Stephanie, if you come to our website, like that's a vetted, high quality tool. If you have that pyOpenSci badge on your tool, you know that that tool is vetted, and we're committed to making sure that that tool is maintained over time and it's high quality. And the whole process, if you want to go through and read the review, everyone that was involved, all of the checks that were, passed, all of the feedback that was responded to and how it was responded to when fully open and transparent.
Mhm.
Now, you also mentioned the challenge with maintainers doing all this work without funding. That makes sustainability a real challenge in open education. What are your thoughts on that?
This is hard. And in fact, I have to say that this is hard for the entire open, using air quotes here, open world, open source, open education, open peer review. Maintenance is the kicker because it's really a lot easier conceptually. It's a lot easier to fund new cool things than it is to maintain those things over time. And volunteer labor is amazing, but volunteer labor is really tricky because you have time in certain blocks and people have different goals with their, time of like what they want to work on. And that just is complicated and challenging, but it's wonderful. But I'll tell you the model that I set up at Earth Lab that worked in an academic setting. So we had multiple funding sources in the Earth Analytics Education program. So one of them was tuition, which I alluded to. So we had this graduate program that was bringing in money that I could pay my staff and myself to teach courses and develop content. And so as a part of that effort, we also would update the content and maintain it through that funding. Another way of funding it was when we wrote grants, and I'm going to use the tribal college. I wrote in a chunk of effort for Earth data science lessons and making sure that there was content that they could take back with them to bring into their courses. But the bottom line of what I'm saying is that, if you're maintaining these materials, think about ways of writing in some support for them over time. And you might need to be a little bit clever in terms of what is the new thing that you're adding, the value added to the community when doing this. So there's no perfect answer. But one thing I do want to advocate for that I think is important, at least for just getting funding, if you're looking to write grants or getting funding in some way that's not a direct revenue stream of advertising or tuition or something like that, where you have that kind of business model, is thinking about collecting metrics. I use Google Analytics. There's lots of other platforms for like web metrics, but some of the things that you can do with those types of platforms is at least have the metrics of like, we have X million people from X countries. And those are metrics that really show impact. And so it's the thing that you can write into a grant that says, we do have a user base of these lessons, and this is the impact. And maybe then you could have some, if you have surveys or feedback from users or comments, you could have some quotes and some of that qualitative data of like, this is having an impact. And so thinking about that early on could be helpful, but it's still not really addressing the issue that you're bringing up of it's really hard to bring in the money needed to maintain the resources.
Yeah, it seems that there's no perfect maintenance solution for open science. At least not yet. But I imagine folks are working on it. One last question I want to ask you. When I talk to people about open science, I'm always hearing about open data and open source, but I've never really heard people mention open education. Where do you think it currently stands in terms of people's adoption, and what are your hopes for the future?
That's a great question. I have a few thoughts on that. I mean, I think a lot of me wonders if we put this term open education around this idea of putting things online and making them freely available. And some of me wonders if there's a lot of people out there that are doing this type of work and just not labeling it as open education. But I think that one of the challenges on the education side of things that probably parallels open source in many ways is that, as we've discussed earlier, it's really hard to do that really well. And if you're at a institution that's profiting off of learning and teaching, there might be some adversity associated with putting all your content online for anyone to use. So there's business model and licensing challenges. I'm really focused on the open source piece because I see a huge issue that really is a threat to open science, right? So if you're an open science advocate and you're using open source tools, but you're not supporting those tools, like, open science isn't going to survive in that environment because those tools are core to everything that we're doing. And so, if we can increase awareness in the open science community of the fact that these open source tools are driving everyone's work, and that there's such a disconnect between that and the value that they add to open science, and the fact that they drive open science, and the fact that often they're not credited or cited in papers, but yet they're driving all these workflows. I just think that that's so important. And so I hope that we can work together as a scientific community to increase awareness around the value.
I think, as Leah said, raising awareness about open education tools might simply be a matter of teaching people the term open education. I mean, YouTube is a giant repository full of free educational tutorials. So there are lots of people doing this work. They just don't necessarily see themselves as open educators in the open science movement. I wonder how many of you, my listeners, are open educators. If you have been publishing and sharing free science tutorials online, then I officially welcome you to the open education community. In our next episode, we're talking about a very timely topic. I'm sure you've been seeing all the artificial intelligence art that's been popping up all over the place. People are definitely polarized about this stuff, particularly due to some of the ethical gray areas surrounding the creation of these art apps. ChatGPT also has everyone in an uproar. This language model can write human-sounding essays about any topic requested. Definitely a challenge for professors evaluating plagiarism. So next episode, we'll talk to a researcher to explore the challenges with AI and how we might be able to make AI more open. In the meantime, connect with Leah and learn more about her work at pyOpenSci.
You can go to our website, pyopensci.org. And if you're interested in learning a little bit more about me, I've been doing a lot of blogging around open education. So you can go to my website, which is leahwasser.com.
Follow the Down to Earth podcast on Spotify and Apple Podcasts. And send some love to our sponsors at IEEE_GRSS on Twitter and Instagram, and IEEE Geoscience and Remote Sensing on Facebook and LinkedIn. This episode was produced by Nicole Bedford from Nicole Bedford Films with help from me, Stephanie Tomampos. Graphics and design by Mylene Briggs of Kila Media. And a special thanks to Yvonne Ivy Parker and Keely Roth for their support. I'm Stephanie Tomampos, and you've been listening to Down to Earth.